Howdy, howdy, compañeros. We're taking a look at multiplying and dividing rational expressions. So this is going to be interesting. This is going to be good stuff, I tell you what. It's going to combine all of our friends. It's going to combine polynomials, factoring, fractions, multiplying and dividing. It's like a party of math all right here on the internet that we can like participate in and hang out at and talk to all our buddies and catch up. Hey, how have you been doing factoring? I missed you. It's going to be great. In fact, let's start with a recall. I imagine that the skill that will require the most practice of our old amigos is going to be dealing with fractions. So recall, how would you multiply 2/15 by, I don't know, 24/8? Okay, so I just had a suggestion. You could multiply straight across. So 2 times 24 is 48. And 15 times 8, 80 plus 120, is it? 80 plus 40? I think I got it. And now I'm not done yet. I've got to simplify this. What goes into 120 and 48? Well, yeah, you could divide by 2. Does 8 go into them? Well, 8, yeah, that's true. Actually, I could have simplified this before I even got started. I think 12 goes into these even. 12 goes into this 4 times and into this 10 times. Either way, you could have, right, we all would have reduced it by something and tried to reduce further. And then let's see what goes into both of those. 2, and 2 goes into that twice, into that 5 times. I don't think that works. So 2/5 is my answer. So that's one technique. What I want to point out is what actually kind of happened on this reduction step is I broke this into its factors, where I thought of this as 12 times 4 over 12 times 10. And I was like, these 12s, we don't need you. Get out of here. And we just canceled them out, right? Or I thought of 4/10 as 2 times 2 over 2 times 5. And when I wrote them as their factors, I could more easily see what would cancel out in order for me to get my answers. Now, that's not the only way you could have done this problem. I'll throw a big or right here. Or we could do what's called cross-canceling, is what it's often referred to as, in which I could actually pre-cancel diagonally when possible. So 2 and 8, between 2 and 8, what goes into both of those? That's 2. 2 goes into that once and into that 4 times. And between 15 and 24, I think 3 goes into that 5 times, and in 24, 8 times perhaps. And now by cross-canceling, what's nice is when I multiply across, I'm multiplying smaller numbers, right? Because maybe you guys wouldn't have known what 15 times 8 was. It would have been scary, right? And then once you got it, we had to figure out multiple times to reduce it. So it's actually better to reduce first, simplify first, and then multiply, so my numbers will be smaller from the get-go. So 1 times 8 is 8, 5 times 4 is 20, and then I could reduce both of those by 4, and that's 2, and 5, and there's the same answer. So this technique is called cross-canceling. All right. All of these techniques will be helpful with today's lesson of multiplying and dividing rational expressions. So here we go. Let's jump into our first for reals example. Bum, 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 ba-dum. Here we are. Exemple. Let's say I want to multiply the following. Multiply the following. Here we are. If I've got 2x squared over 3x to the 5th, and I'm multiplying by 12x to the 7th over x to the 3rd. All right, technically, we've done problems kind of like this before back in the days of properties of exponents. So this is kind of review-ish right now. That's fine before we get crazy. So I'm going to try cross-canceling. Now, this is all multiplication across. There's no plus signs or minus signs. So because of that, I can start canceling out right away. All right. If there was like a 12 plus x to the 7th, hold your canceling train, friends. That thing might not work out so friendly. So let's see. I see between 3 and 12 I could cancel something out. What goes into both of those? Trace. That's right. 3 goes into 3 once and into 12 4 times. Now, keeping with the cross-canceling concept, between x to the 5th and x to the 7th, I could cancel out 5 of these with 5 of those, leaving x to the 2nd. And on this diagonal, x squared, I could cancel out the x squared with 2 of those, leaving x to the 1st. So let's multiply across now. So 2 times 4 is 8. And up top, all I've got is an x squared. And in the bottom, 1 times x is x, right? And then I could do my final canceling, which you guys also know that is like subtracting the exponent from the small guy from the big guy. But I could cancel out this x with one of those, leaving an x to the 1st, right? So I would be left with 8x as my answer. All right, so in a sense, as long as it's written as the product of things, as factors, we're good. We're good. That's all you got to do. Now it gets a little bit more interesting if these problems aren't yet factored and tempting for us to make mistakes. So in this next example, let's try to simplify the following. Here we are. Let's say I want to simplify this problem. 4x squared minus 2x over 2x minus 1. Now, I've got some eager students, and I'm actually glad that they would try this. In my heart of hearts, I'm like, all right, I'm glad that you were thinking about simplifying in that way. Where they would see, aha, 2x and 2x, those things cancel out. But the problem is, I can't cancel that. All right? That 2x was linked in with this minus 1. All right? And this minus 2x was linked in with a 4x squared. So you actually can't do that. In fact, the only thing that a 2x minus 1 would cancel out with is if I had another entire 2x minus 1. That could cancel out with that. But you can't cancel out piecemeal when you have plus or minuses floating around. Okay? So the first thing I'm going to do is, let's see if I can factor any of these things. So in the numerator, is there any way I could factor that? I could yoink yoink a 2x. Good eye on that, Hank. Good eye. So that would be 2x times 2x is 4x squared, and 2x times negative 1 is a negative 2x. And on the bottom, can I factor that? No, that's just like a linear binomial, nothing to do there, can't GCF, nothing. And now that I've got this factored, this is written as the product of two things, right? I could view this as its own thing. Now I can cancel these out, right? An entire 2x minus 1 cancels out with a 2x minus 1. I can go fruit ninja on that, as I like to think, and swing, swing, just cancel those out. And I get my answer of just plain old 2x. Okay? So I do want to point that out, is maybe I'll even write a special little note to us. Don't cancel out until it is all factored, or until we factored it all. Bam. Good little advice. All right, that was the lesson, the moral of the story behind that problem. All right, so that was just a simplified problem. Bless you. Again, bless you. Today's lesson, though, is about multiplying and dividing rational expressions. How embarrassing. This was just simplifying. So if I'm going to multiply two things like that, let's try it. Let's say I have x squared minus 9 over x plus 3 multiplied by x squared plus 5x plus 6 over x squared minus 6x plus 9. Whew. This is crazy loco. Now, in some ways, the unfortunate thing about these problems is there can sometimes be as many as 4 separate factoring problems in this, where I actually have to try to factor this, 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 and this. All right, so we are going to have to be factor experts. Factor experts. Factories of factoring, where we get raw materials of polynomials and we turn them into their factored outcomes. So let's see, does anyone know if I could factor x squared minus 9? X plus 3, x minus 3, I like it. And the reason he chose that was the a squared minus b squared pattern. All right, and I'm not even gonna be writing out scratch work for factoring anymore. You might not be at that step. You might need to, on side scratch paper, write out how you'd factor some of these things. Okay, and that's fine. That's fine. But for the sake of getting through these problems, I'm just gonna do it to it. Let's see. Let's try to factor now. Actually, I could leave this as multiplied by another fraction, or I could kind of preemptively use this strategy that Evan mentioned of just multiplying across and writing it as one big fraction. Yeah, he mentioned that earlier back at the beginning of the recall. Yeah, isn't that great? So, I'm actually just gonna think of this as one big gimungo fraction here. It's gonna be awesome. So, how do I factor this? Well, I would have found the factors of 6, which are 1 and 6, 2 and 3. Which of those add to be 5? Well, that's the 2 and the 3. So I'm gonna have an x with a 2, x with a 3, and that's gonna be plus plus. If you need some practice factoring, I'm gonna recommend send you on over to my man Salman Khan. That's right, good old Sal will hook you up, teach you how to factor, get your skills sharp. Yeah, he sent me an email the other day too. It's pretty great. I'm like, yo Sal, what's up? I wasn't as excited about as getting an email from Jacob as I was with Khan. You know, like, I mean, Khan, I was like, whatever. But Jacob sending me an email, I was just like, dude. It was pretty awesome. So here we've got this guy. Now I could factor this using the same pattern, 1 and 9, 3 and 3, or I could actually use a pattern. That's a squared minus 2ab plus b squared. Yeah, that's fine either way. I'm going to use the pattern where this is just going to equal x minus 3 all squared, I believe. Or x minus 3 times x minus 3 if you like that better. Whichever way you like it, that's fine. I'm going to write it shorthand because I like saving space and time, you know what I mean? That's right, it's like I'm a superhero saving space-time when there's a tear in it. Like this. Space! That was scary. My goodness. So let's go Fruit Ninja on this. I don't know if you guys have ever seen the movie Good Will Hunting, when like little kid janitor from Boston, right, working at MIT or whatever, like this math professor realizes the kid's got talent, and he's all like, yeah, I'm going to teach you math, and you have father issues, whatever. And but there's a scene where he's like doing a big problem on the board, and then like he gets to like a point kind of like this, and then him and the professor kind of both smile amusingly, and they stand up and just like grab some chalk, and they just go Fruit Ninja on that problem. They're just like, and just like canceling stuff out like crazy. This is the best moment of all these problems. I love it. Here we go. Yeah, I believe you are correct, yeah. So let's go Fruit Ninja on this. What do you see that could cancel out? Oh, well, are you saying pairs of those things? So x plus 3 in either this one or this one, doesn't matter. Swing, swing, right? I cancel out the x plus 3, x plus 3. And you were also saying that the x minus 3, is that what you were indicating? Could cancel out with one of these x minus 3s, not both, just one, right? So that would reduce that exponent down to 1. And I can't cancel anything else out. So maybe not as cool as that Good Will Hunting moment. I should find that on YouTube and watch that right now. That'd be pretty great. If it's available, I don't know. So that'd be x plus 2 times x plus 3 up top over a single x minus 3. And this is my simplified, canceled out, rational expression where I just multiplied those two at the top and just went shrink, canceled everything out. Well, this x minus 3 would have canceled out with one of those x minus 3's, not unlike when I was doing this, where I could cancel out the 12 and the 12 or the 2 and the 2. When you have the same thing and they're all factored, as long as they're factored, if there's plus or minus signs, it's a no-go. But if they're all multiplication, then you can cancel out. And yeah, that square literally just meant there was 2 of these x minus 3's there. So that's why I canceled it out with one of them. Not bad, not bad. All right, guys, we're doing good. We're doing good. I've got one more recall, one more example. We are awesome, right, Hankford and Evan? Yeah, good stuff. Let's take a look at this recall. What if I asked us to solve the following problem? What if I had 2/3 x equals 1/5? Now, how could you solve that problem? This is being multiplied by x. Okay, so that is the elegant solution, and I like that. That's where we're going to lead to. Now, if I didn't know that solution, technically I'd say, well, I'm multiplying x by 2/3. The way to undo multiplication by 2/3 is you'd have to divide by 2/3 on both sides. And you might say, what? Stacko-frac? What does that even mean? This is like a fraction on top of a fraction. This is crazy. Or it's like a fraction with fractions inside of it. What? Right? That's like inception of fractions right there. We don't know what that means necessarily. Well, maybe you do, but it's kind of weird. The other way to think about it is multiplying by the reciprocal, which is what Connell suggested. Multiply by 3/2, where I've got x equals 1 times 3 is 3, 5 times 2 is 10. Bam. So the idea is, instead of multiplying, let's see if I can spell, instead of, dividing by a fraction, what did we do? Comma. What was our advice? Multiply by the reciprocal. Bam. So, let's do one example of division of rational expressions. Whew. Here we go, friends. Dun, 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 dun. Not really. Not really. I don't think so. Here we go. If I've got x squared minus 1 over x squared plus x minus 12 divided by x plus 1 over x squared minus 16. So, loco I know co. Man, that's the best catchphrase ever. So, I'm dividing this guy by this guy. And what was my advice just a moment ago? Instead of dividing by a fraction, multiply by the reciprocal. So my first idea is don't divide, multiply by the reciprocal. More like refliprocal, am I right? Yeah. Yep. I'll just edit in like a laugh track right there in this video. It'll be great. Multiply by the reciprocal. X squared minus 16 over x plus 1. So I just changed it to multiplication. Now it's exactly like the other problem. Normally, I wouldn't even rewrite this step. In the process of doing this, I would have already started my factoring. But for the sake of our notes on this one example, it's probably not a bad idea to write that step down. Wow, that was crazy. So let's start factoring, friends, because I know you guys will be tempted. One of you at least, maybe even a third of you, all right, not to use fractions because I know you guys don't necessarily like fractions, are probably going to start doing this and just be like, oh, x squared, bam, cancel those out. This x with one of those, bam. And you're just like, whoa, slow your roll. I can't cancel those out until they are factored. All right, so that would be, I would write literally illegal cancel is what I would write. Illegal. So let's see, x squared minus 1. I can factor that using my a squared minus b squared. I think I can use the same tactic over here. This is a regular find the factors of the c, 1, 1 and 12, 2 and 6, 3 and 4, and this one's already factored. So that's my factor plan here. X squared minus 1 is going to become, I guess I'll move this equal sign now that I wrote all my garbage work in the way. Bless you, bless you. So this is going to factor be x plus 1 times x minus 1. Also, now that I'm multiplying, let's just write it as one gymongous fraction. Gymundo. X squared minus 16 factors at x plus 4, x minus 4. Difference of squares, friend. You guys are going to be so good at spotting those. Like, you're just going to be like, bam, perfect squares. They're being subtracted. Bam, sum and difference. You'll be so good. I love it. So let's see. Here, I'm looking for the factors of 12 that subtract to be 1. So that's 3 and 4. So I'm going to have x with a 3, x with a 4. And who's a what's it? What are their signs? Plus 4 and minus 3. They multiplied to be negative, so their signs had to be different. And they had to be positive, so the more influential of them was the positive. I like it. And then x plus 1 hanging out. And here we go. Fruit Ninja! Here we are, here we are. All right. Ready? Swing, swing, and swing, swing. Just canceling out left and right. Look out. Someday I'm going to program an app where it's just all like factoring problems and you're swiping your finger across the screen to cancel stuff. It'll be great. I'll sell millions. So, there we go. Problem's done. Technically, one of the things I want to point out about this and the previous problem, I'm leaving my answers in this factored form. I kind of find that more helpful. Although you could, if you wanted, you could FOIL that out and get like x squared minus 5x plus 4 and x minus 3. Technically, it is equal to that as well. I kind of like this form better. I believe your book writes it in that form as well. But this is not wrong. It's just, come on. We like factored stuff. Factoring's so cool. So that's all you do for that problem. All it had was that one extra step where I'll just write mult by re, and I'll write flip rocal. Bam, flip. Man, that's so awesome. So anyways, that's the whole lesson. Not bad for 22 minutes and 30 seconds. Bye, friends. Bye.